Section 2.4, graphical displays of data. In this section, we have three types of graphs that we will accomplish. We got our histograms and our bar graphs. Those are the first two. Those are being highlighted first because they are very similar. They both use rectangles to make the graph. However, there is a big difference between them, and it depends on the type of data being used. A histogram uses quantitative data, so data that would be numerical in nature, such as the heights of children, number of hospitals in a state, number of libraries in a city, yada yada. That would all be quantitative because it's number of. Qualitative data is data that's non-numerical in nature. There's different types of it, and stats class will explain more. But things that are not numerical, the video example we have are the movie titles, and then compared to how much money they made. So since the titles of the movies aren't numerical, that would make it qualitative data. But there's a warning though. When you are making a histogram or a bar graph, do not introduce a bias. Rectangles should be equal width. If one of your rectangles was wider than the other, then what will happen is the viewer would think that that rectangle is more important than everything else. So please be careful of that. Also, make sure that your axes are properly marked. It is very easy, if you wanted to, trick the viewer and make it look not as important. Honestly, just do a Google search for, I would say, faulty histograms or faulty bar graphs, and I'm sure you'll see plenty of examples. Sometimes you might also see, I don't know where my cursor is. Oh, I gotta plug it back in, excuse me. Where's my little USB port? It's over here. That song is brought to you by, I don't have a sponsor. All right, let's try this again. What does this do? It's not doing anything. Again, not editing any of this out. Oh, there we go. Now, there we go. So you might see on a histogram, for instance, a little like lightning bolt. And what that means is that values were skipped. So for instance, if your x-axis represented years, you might see a little lightning bolt there to start at, I'm just making this year up, 1970. And what that is doing is it's cutting out a whole bunch of years before then. And same thing over here, the y's might be skipping. You might see like 500. So they skipped over the first 500, but then after that it counts by 100. So basically what that means is they skipped a whole bunch just to make the graph easier to read. Well, easier to read, but you have to be careful because it could introduce a bias, which again means that some data, or the data is being misrepresented. I think that's the best way of saying it. All right, we got two videos, frequency and relative frequency histograms, that's one video, and drawing a bar graph, that's another video.